welcome back to the Man Cave Workshop. Thanks for joining me. And on the bench we've got another radio. The back's open. Is that clicking? Wow, this is a Roberts R300. And looks like we're going to have fun with this one. Oh, inside it there's well, that's good. There's a button and two brights. Okay, let's have a look at the buttons. Yeah, so we've got a bright on the buttons and we've got two missing, but we've got three buttons, so we've got a spare button as well. Now this face looks like it's had a burn on it there. It might be something we can get off. General condition. It's an old radio. It looks it as well. Okay, let's open it up and have a look what's inside again. So we've got a sea of these, are they Hunt capacitors? Don't know. They look like they'll need addressing. We've got 1, 2, 3 AF117 transistors. We've got kind of a battery snap, a little bit missing there. So let's put some power to it, see what happens. It takes 9 volts. Let's get 9 volts on the power supply. Is this set off? Yeah. Okay. Let's just switch the supply off and get 9 volts on it, and then switch it on, and then switch the radio on. And we do have a bit of noise from the volume pot. But that's about it. So I suspect that these AF117s are playing up. So what I'm going to do before we carry on is, what happens with these, you probably know, is that they grow whiskers and they short out to the shield, which is this outside bit. Now there's 4 legs on these, and one of them is the shield leg. So sometimes you can tap them and it brings a set back to life by knocking the whiskers off. This happens with age. But what I'm going to do in this case is I'm going to get my cutters out, and I'm just going to snip the shield legs off so they're out of circuit. Okay, I'll just pause while I do that. So okay, we're back, and we snipped the shield legs on this one and this one, and now when you turn it on, it still makes no sound. Oh, there we go.
He was touching a hard first touch. Yeah, it was a bad first touch. I think that was about 13, 14 passes here. I think that's the most.
So there we go. There's a good sign. After snipping the shield legs on these two, it does make noise like a radio should. So I think what we'll do next is pull it out of the chassis to have a better look at everything. Okay. Okay, let's get this out of its chassis. Looking at it, there's 2 wedges here, and it looks like there's 2 retaining screws underneath that are holding them. So let's pull them out. Let's get the right size screwdriver so we don't strip the head. It feels like it's been a little bit stripped anyway. Not sure if it's been out before. Oh no, that's not the right one. Let's go with what we were using. It's a pet hate of mine, stripping heads on screws, and these look like they've already been stripped. pull this one out. We're still in shot, just about. Okay, let's pull these wedges out and see where that gets us. Oh, there's bits falling out. Okay, let's get this out. Gently does it. Do we have to take the knobs off? I'm not sure. Is it going to come out? Not sure. Oh, there we go. Again, being pretty gentle with everything, because it's an old boy, this one, isn't it? There we go, we're out. Let's have a look at the other side of the chassis. Yeah, okay. So we can actually work on this set without... No, we should take it cleanly out, shouldn't we, really? Do these pull off? No, everything's soldered on. Okay. Oh, look at that. There's the other part of the battery snap. It was hidden underneath it. It fell off. That's good. At least we've got that. So let's warm up the soldering iron and get it clean out of the chassis. Clean out of the chassis, did I say? Clean out of the case. Okay, I think the soldering iron's suitably warmed up. So let's start by taking this external... Are we in shot? Kind of. Let's start with taking this external air wheel off. Which don't burn your fingers. Look how easy it's coming off. Tell you what, should we speed this up a little bit? Let's snip it off and then clean it up after. There's plenty of wire there. Okay, let's get the speaker wires off. Turn it up a little bit so you can see. Wedge something underneath it that it doesn't fall. Okay. Nope. Let's snip them off as well. Clean them up after and get rid of all that solder when we get the speaker out, because this is going to be a full hands-on job, I think, this radio. There's going to be a lot to do on it. Oh, there we go. Pop that on one side. Let's have another look at this. So there's 3 AF117s there. I should imagine these are the output transistors. Looking at these capacitors, they say TCC on them. These guys down here say Hunt. Really like the look of the set as it is. I don't want to yank these out and then put modern capacitors in it. I think it would spoil the look of the set. So for now, what we're going to concentrate on are these transistors, because it was working with the shield legs taken off. So what we'll do, we'll pull one out at a time. Let's see if this Fevite aerial comes off out so it can go out of the way. Yeah, as you can see, I've really slowed down on this set because it's quite an old set, so you have to You have to take care with these things. Okay, so that had a rubber mount. That's quite delicate. I don't want to mess about with that too much, just so we can see what else is in here. And before we go any further with this set, I need to download the schematic, have a good look at it, try to get more understanding on how it works before we go all crazy pulling things out. So these three definitely need doing. Okay, so I'm going to pause the video now and have a think, have a look. Okay, let's zoom you in a little bit. There we go. I've had a look online at the schematic. I've not downloaded it onto paper, but I think what we're going to do is really want to keep this set looking original when you open the back to change the battery. Apart in regards to these capacitors, anyway. I think we're going to pull these AF117s and replace them with a German transistor called a GT322, I think, or 332, 322. I've got some of them in stock. So I'm going to lift this one out first, and we'll have a look at it. So here we go. I hope I've got the lighting right on this. This is where it gets all a little bit confusing for me. I pulled out this AF117 from here, and what I've done is done a little drawing for myself. Let me get a pointer, so I know how it came out of this slot here. Can you see that? Drag that up so you can see it properly. Still left a couple of the insulating wires on just for reference for now. So the way it's come out is that the shield went here. The base, there's four on here. There's a base, emitter, shield and collector. They've got to go in the right way when we replace them. So shield, base, collector, emitter. That's how that came out of the set. Now I'm replacing them with these guys, which are GT322Bs, and they have, let me drag them up, they're really tiny. They have a little tab on the top of them, and the pinout for these goes shield, emitter, base, collector. So I've tried to colour code these so when I put this in the set, that I get all the legs going to the right pin-out points in the set on the board. Let's just get a bit closer there so you can see my little diagrams of what I'm doing. So I'm going to replace that with this, and then test the set to see if it still works, because we've only pulled this out. Can easily put it back in. They can be zapped, these, by putting a load through them to blow the tin whiskers off. Yeah, so let's put this little guy in and see if the set still works. Okay, carrying on. I've pulled a couple of the AF117s out of this set, and I've got one of them here. I've got the GT322s that they're okay as a replacement, but when you put them in the set, it sort of loses its look. I do want to keep this set looking original. So going back to the AF117 transistors, the reason these fail is that they grow tin whiskers. So what happens is, and there's videos on YouTube about this, the shield, which is this connection here, connects to the outside here. So that's the shield. And what happens is these tin whiskers grow, and then they short out to either the base, emitter or collector. This is as far as I know it. So what you can do is and there are YouTube videos out there, is to get the emitter, base and collector together and then throw a charge from a capacitor to the shield to burn off these whiskers. So that's what we're going to do. For now, what I'll do is show you. This wire here is the shield, which is, you know, this one, and these three here are the emitter, base and collector. So join them together with a clip. Oh, this meter is just set to continuity to do a beep when it gets a connection. So I'll join them together, and the shield wire isn't touching them, but if I touch the case where the shield's connected to, well, here we get a short as if I connect it to the actual shield wire there. So what I'm going to do is, I haven't got, really you need about 60 volts to throw through it through a capacitor like this one. This is it's a 100 volt 220 UF capacitor. So really we need to charge this up to 60 volts and then have it touching the three legs of the emitter, base and collector, and then just discharge itself to the shield to hopefully blow off have I just said that? To blow away all these whiskers, and it should cure it. So you can see now it's got a short. Let's try get rid of that. First of all, before we get all crazy with 60 volts, let's charge this up to my DC power supply unit goes to 30 volts. So let's charge it up to 30 volts. Now, if you're doing this, guys, really be careful. You're charging caps up. If you don't discharge them and you touch the positive and negative, you will get a belt off them. When you're playing with caps as well, the positive lead is always the positive. The positive lead is always a positive, is always the longest lead, and the negative is always the shortest lead on a cap like this. If you put supply on the wrong way round, it will blow up in your face and hurt. Go and have a look at other videos before you try to do this off watching this video. I really don't want anybody to get hurt playing about with stuff like this. So I'm going to charge this to 30 volts now. Let's just measure that. So yeah, that cap's charged to 30 volts. As I take the power off, it will slowly start to discharge. If you look, it's still holding its charge. So what I'm going to do is try to give that's still got 30 volts in it. I'm going to discharge it now. You probably heard the spark. I'm going to wire this up to try and throw 30 volts at 220 UF through this AF117. Now the way I'm going to do it, there's many different ways of doing this, is I'm going to keep the meter on this capacitor so I know what charge is in it, and then I've got a lead running off the capacitor, and I've just connected it to the base, emitter and collector on the capacitor. I've got the shield wire hanging out this way, so I can then, after this capacitor's charged, just touch the shield wire with the capacitor to hopefully zap this AF117 with 30 volts. So let's charge the capacitor up. You see on the meter it's charging up, it's got 30 volts in it. So now let's touch that and watch it quickly discharge. It doesn't look like it's shocking it too much, does it? It's probably not going to clear probably not enough voltage there to clear it. Let's run it all through anyway. Let's make sure we got good contact there. That should have just blasted it quick. It's probably not enough voltage behind it. We might have to go up to 60 volts with this. Okay, let's pull the, and remembering that this cap is still charged. So let's discharge that again. There we go. Let's see if that did anything at all. I doubt it very much. So back at ohms for a continuity test. Just testing on here. Oh. It might have cleared all the shorts. Remember before it had continuity? It might have blown the transistor, don't know. But it definitely is not shorting out now. I'll just double check. Never know, that might have cured it. Okay, I'll run through that again and with the other ones, and we'll see if then the set works with the shield on. Okay, so I'm just running through it again. Got the shield wire sticking out there, you can see it on its own. The base emitter and collector are connected to here. The capacitor's got 31 volts on it. Let's get that in view. And touching the shield wire now, it doesn't drop. The current doesn't drop, and it shouldn't do, because there's no way of it to get through anymore. That's a promising sign. Again, I don't know if I'm doing this right. Please be careful if you do this at home. Please remember to discharge your caps. And let's do the other two in this set. Put the AF117s back in this set and see if it works. So I know we said let's get them back in, but here's the other AF117. You can see the shield wire hanging out there. And we've got continuity, so we've got shorts. So I'll just pause while I give this one the same treatment the other one had, and then we'll see if we've got any shorts on that one. So it's had the same treatment, and if you look at continuity here, we've got continuity between here, the base, emitter and collector wires. The shield wire and the shield itself, the outer case, we now don't have any continuity at all. So it appears to have worked again, which is good news. Okay, I thought we'd stick this in the in this tester that has a transistor bit that you stick in. I haven't a clue. I've never tested transistors. I don't really know how the pinout should go, but I've left the shield wire out and just use the first three inputs on this. Let's just press test, see what happens. So here we go. It says it's a PMP. That looks like a transistor to me. Perhaps we've cured that one. Let's test the other one we did. Get the wires right. There's the shield. Stick them in them first three. I'm probably doing it all wrong, but I did get a reading then that seemed quite positive to me. Stick them in, lock it in, test. That one says the same. Very good. We'll carry on. So it's a bit dark, this video, isn't it? Just realised. Sorry about lighting. So there we go. I've bench is a mess. These two AF117s here and here, here and here, have been zapped. This one hasn't yet, but we've put them back in. Let's see if the radio works. Volume, we've got power to it. Let's try medium wave. It sounds like a radio.
Well, interesting. In fact, he was the lightest he's ever been. That's you know what I mean? So it's over 19 stone for this fight, any boys?
Yeah, it's 19 and a half, Danny. Listen, mate, we've got to break it there. We could talk to you all night, but someone's in the ear.
So yeah, it is working now without having to tap them. Let's just tap them just to see. This one.
With Betfred. Wilder versus Fury 2. Whenever you.
So yeah, it's working, and these two have been zapped. How far are we going to go with this? Are we going to do these capacitors? Are we going to do them? So original. I think for now, I mean, zapping these and taking them in and out for me is quite a big deal. I've not done them very often. I like to keep the set working, looking original. I do like to clean them up. So the next video, we'll do some case cleaning on it, and then it's good to have a little rest from the electronics, and we'll think what we're going to do with the rest of this this board here. Okay, so as always, thanks for watching. Voice has been a bit serious again on this one, because we're doing some quite intricate work on this. I hope you join me in the next video, and as always, be good to each other. Catch ya.